All right, so in this video, we're just going to talk about the basics of matrices. And I have this split up into 3 different videos to hopefully make it go a little bit easier. So first off, what is a matrix? A matrix is a rectangular grid. Let me get my pen working here again. Of numbers, sometimes called an array. It is arranged in rows and columns. So we have an example here of matrix A, and the first thing we're going to learn about is its dimensions, because as we look at doing operations with matrices and multiple matrices, there has to be, in some cases, certain characteristics about their dimensions in order for us to do the operations. So as we look at our matrix here, matrix A, we basically has a number of rows and number of columns. So matrix A has 2 rows and 3 columns, is what it has. And then matrix A is basically it's called a 2 and by 3 matrix. And the way we read it is actually 2 by 3. And again, what we have to remember is when we go to name our matrix, it is always rows by columns. And so in our second example, if you want to pause and go ahead and write down what this one is, I'll give you a chance to do that. So as we look at this one in matrix B, it has 1, 2, 3 rows and a total of 2 columns. So this is what we call a 3 by 2 matrix. The elements of the matrix or of a matrix are the individual. Really, it's the individual values. So I'm trying to grab my eraser. They're the individual values in the inside. So these numbers right here. The number of values, the number of elements or entries is the total of the number of rows and columns. So with that in mind, when I look at how many elements are in, if I look at that, I have so I should say total being it's the product. So matrix A up above is a 2 by 3 matrix, and so if we do 2 times 3, we have 6 elements in there, and we have 1, 2, 3, 4, 5, 6 elements there. Matrix M, we don't have that one listed. They just happen to say matrix M's right there. They said it has how many elements inside of it. Well, technically it is 4 by 3, so it has 12 elements. It has 12 parts to it. A matrix element or entry can be identified by its basically its location in the matrix. In general, the notation A, and this is, again, it's hard to see it, it says A sub I and J, refers to the element's location in matrix A. Basically, it's what row and column it is. So they want us to go through and practice identifying in matrix M what number or what element represents M2, 3. So that would be, again, in matrix M, row 2, column 3, what is that number that's there? So in matrix M, row 2, column 3, it would be 0. Identify what in matrix M is the element that's in 1, 2. So that's the first row, and then it would be the second column. Column 3. Sorry, 2. So first row, second column, that would be 2. And then 4, 3 would be down to the 4th row, over to the 3rd, negative 3. All right. So again, we're going to get some more practice doing this real quickly here. So that's what most of this page here is for us to just to working with the identifying what type of matrices we have, the elements. So if you want to pause, work through it, come back, and then see how you did. I would recommend that totally. So I'm going to give you a second to pause. All right, so now again, we want to identify the rows and columns, and so we can name each so we can do it. So this has 2 by 3. It has 2 rows and a total of 3 columns. Matrix K actually only has 1 row, but it has 3 columns. So this is a 1 by 3 matrix. And then matrix M is 1, 2, 3, 4 rows by 1, 2, 3, 4 columns. So this is a 4 by 4 matrix, which is a special matrix that we can do some extra operations to it compared to other ones. How many elements are in each matrix? Okay, so this is where we're just multiplying. So matrix A, 2 times 3 is 6. Matrix K, 1 times 3 is 3. Matrix M, 4 times 4, 16. And then it says consider matrix L, which happens to be a 13 by 7 matrix. How many elements are in matrix L? Well, we would just do 13 times 7, which is 91. So 91. Again, that would be a really, really big, because again, you're thinking about 13 rows. So if we were able to draw it, it'd be sorry, my pen's not working, there we go. It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. 9, 10, 11, 12, and 13. And then we would go 7 columns. 1, 2, 3, 4, 5, 6, 7. So it's out there pretty big. All right, so again, I'm going to change up pens here real quickly and get back to writing here. All right, so let's see if this one works. Identify in matrix A what element is A2, 1. So matrix A, second row, first column, that would happen to be the number 2. All right, matrix K, row 1, column 2. So matrix K, only 1 row, column 2, that would be negative 3. Then we have matrix M, 3, 3. So that would be the third row, third column. That would be the positive 1 that we see right there. And let's see, it says matrix D is a 3 by 2 matrix with in the element of 4 in the position of row 1, column 2. So 3 by 2. So we know this is a 2 by 3. That's a 2 by 3. This is a 3 by 2. So this is a 3 by 2. This is a 3 by 2. And then now we say, okay, in the first row, second column, there is a 4. First row, second column is a 4. So that's this one right here. This has got to be matrix D. All right, last part of this video here says create a matrix that has the following characteristics. First off, it's got to be a 4 by 2. We want in the fourth row, first column, we want a 5. So with that in mind, so as I do 2, 3, 4 rows, they're going to have a 5 in that column, in that first position. And then it says I have 2 columns, so that means I just have two sets of blanks here on each row, 2 sets of blanks. And then now they say the sum of the elements in the first column is 0. So this column right here has to add up. This first column right here if I add up that column, I'm supposed to get 0. Okay? So I automatically have a 5 in the bottom one, so that means what cancels a 5? I could do a -5 is what I could do. I could put a -5 here. And then what would that make the next two numbers have to be? They could be both zeros, is what I could do, or I could choose the same numeral, but have opposite signs so they cancel out. So there's a lot of different options here. I could go, 1 and -1. Again, I could have put 0 in both spots, but I got to make sure that row adds up or sums to 0. Now, the last row, there's no stipulation in the last column. I can put whatever I want in here. So there's like infinite number of possibilities I can do here. Again, you can use positive numbers, you can use negative numbers, you can use 0. So whatever you want to do. They just asked us to make sure it was a 4 by 2, 4 rows by 2 columns. And then they wanted the stipulation that in the 4th row, first column was a 5, a positive 5, and that's what we got. And then we had to make sure that first row, or that first column added up to 0. So we're good there. All right, so next one here is just a little fun one for you to go through and kind of spell some phrase here and kind of go through that process there. So it's just a little extra practice.